In this next section, we're going to talk about linear, compound, and absolute value inequalities. Some notes that I've made up here. I want you to go from the graph of a line. I want you to give me that information in what's called interval notation. Some of you might recall seeing a graph that looks like this with an open circle. Now we're no longer going to use open and closed circles. We're going to use parentheses and brackets. The open circle up here in red, this information, the open circle you're going to use parentheses, and that means not to include the number. Whereas like in number 2, this graph in the old days would have looked like this. It would have been a closed circle. The closed circle we're going to use a bracket instead, and that means to include that number. Okay, with interval notation, you always go from left to right, and I'm going to encourage you to always go to write the graph first, and that helps you write the interval notation. To read the graph from left to right, where are you going to start picking your numbers? You're going to start picking it here at 1, and it's a parenthesis, and you're going to stop picking way out here at infinity. Another note, infinity and negative infinity, so infinity and negative infinity, always use parentheses. Okay? So anytime you write infinity or negative infinity, it's always going to have a parenthesis attached to it. So number 1, the graph here, you start at 1 with a parenthesis and you go out to infinity with a parenthesis. Number 2, where are you going to start? You're going to start on the left at negative infinity, which always has a parenthesis, and you're going to stop at 5 with a bracket. On number 3, you're going to start here at negative 3 with a parenthesis, and you're going to stop at 6 with a bracket. Hopefully that is all a review. Let's talk about how to solve linear inequalities in one variable. Some definitions. A linear inequality is any relationship of the form ax plus b greater than 0, ax plus b less than 0, ax plus b greater than or equal to 0, or ax plus b less than or equal to 0. I want to go up here and remind you, a linear equation was of the form ax plus b equals 0. So now we're no longer going to have the equal sign. We're going to have either a greater than, less than, greater than or equal to, less than or equal to. Those are linear inequalities. The solution set to a linear inequality contains an infinite number of elements and can be expressed in either set builder notation or in interval notation. I'm always going to ask you to do it in interval notation. And the difference, set builder notation is something like x such that x is bigger than, say, 7. That same problem expressed in interval notation is going to be 7 to infinity. So set builder notation contains an inequality. Interval notation is written as an interval. I gave you some examples. X plus 4 equals 0. That's a linear equation. The answer is just x equals 4. I would have written that as x equals negative 4. But they're just doing negative 4 in the braces. The graph of that is just a point over the value x equals negative 4. An inequality, x plus 4 greater than or equal to 0. The answer in set builder notation is all x's such that x is greater than or equal to -4. The solution set expressed in interval notation is bracket -4 comma infinity close parenthesis, and on the number line you start at -4 and shade to the right. Let's go do some examples. First we're going to talk about properties of inequalities. Sorry. The only property I really want to call your attention to is number 6. If C is a negative number and you know that A is less than B, if you multiply or divide by a negative number, you flip the sign. Notice we said if A is less than B, if you multiply by a negative number, it becomes AC is greater than BC. Same thing holds true. If C is a negative number and A is less than B, then A divided by C is going to be greater than B divided by C. So I'm going to say this. Anytime you multiply or divide by a negative number, a little flag is going to go up. And that little flag is going to remind you, oh yeah, I need to flip the sign. If you divide by a negative number, flip the sign. If you multiply by a negative number, flip the sign. If you multiply or divide by a negative number, flip the sign. Or flip the inequality symbol would be better. If you multiply or divide by a negative number, flip the inequality symbol. Let's go do an example. -5x minus 6 greater than or equal to 24. My goal is to get x by itself on the left. To do that, I need to add 6 to both sides first. I'll have -5x is greater than or equal to 30. Now divide both sides by -5. I divided by a negative number. What happens? A little flag went up, and I'm going to need to go over here and say, okay, less than or equal to. I needed to flip the sign. And I get x is less than or equal to -6. From here, I'm going to encourage you to do the graph. Here's -6. I want all the values less than or equal to -6. So am I going to shade to the right or to the left? And the answer is I'm going to shade to the left. All the numbers less than -6. And I want less than or equal to, so that means I want the bracket. The answer to this problem in interval notation, I start at -infinity, which always has a parenthesis, and I stop at -6 with a bracket. That's my answer. Number 2. Number 2 has fractions in it. I want to get rid of those fractions. What is the LCD? What is the LCD between 2, 10, and 5? What number will all three of those numbers go into? And the answer is 10. So I need to multiply everything, every term, by 10. When I do that, 2 goes into 10 5 times. I'm going to distribute the 5. I get 5x minus 20. The 10s will cancel. I still need to distribute that negative sign though. And I think I warned you earlier this week, when you distribute that negative, when that negative is out front, don't forget to distribute it. I get -3x minus 4 is greater than. 5 goes into 10 2 times. I need to distribute the 2. Oh, not really. I'm just multiplying. 2 times -3x. Sorry. negative 6x. Are there any like terms to collect on the left? 5x minus 3x gives me 2x. Negative 20 minus 4 gives me negative 24, greater than negative 6x. If this were an equation, I would tell you to move the 2x to the right. But it's an inequality and we want to get our x's on the left. So I'm going to tell you to add 6x to both sides first. 2x plus 6x is 8x. Minus 24 greater than 0. Add 24 to both sides. And I get 8x greater than 24. Divide both sides by 8. Do I need to raise a flag? And the answer is no. 8 is a positive number, so everything is okay. Nothing changes. And I get x bigger than 3. On my graph, I want all numbers that are bigger than 3. So I want to shade to the right. Do I want 3? No, because there's no equal to here. So this is a parenthesis. My answer in interval notation, I have a parenthesis, I start with 3, and I go all the way up to infinity, which always has a parenthesis.